What's up, guys? Today we got actually a really quick integral, so long as you remember your inverse trig. So, our integral today is the integral from 0 to 1 of arcsine of x squared all over the square root of 1 minus x squared. And here is a perfect time to do a u substitution, where we let u equal arcsine of x. This is because if you remember your derivative of arcsine x, du will equal the square root of 1 minus x squared, dx. Or my bad, it's 1 over the square root of 1 minus x squared dx. And it's perfectly here. We have arcsine right here as our u, and then because the square root of 1 minus x squared is in our denominator, it's the same as 1 minus the square root of 1 over, or all that stuff, whatever. So essentially we have a perfect u substitution right here. So on the inside of the integral, we will have just u squared du, and that's it. Only thing we'll have to change is our bounds. So if we plug in 1, arcsine of 1 is going to be pi over 2, top of the unit circle, whatever, so pi over 2. And plugging in 0, arcsine of 0, we're just going to use 0. So we're just going to have the integral of 0 to pi over 2 of u squared. U squared is extremely easy. We're just going to reverse power rule. We'll get u cubed over 3. And we have to evaluate it from 0 to pi over 2. Plugging in pi over 2, we'll get pi over 2 all cubed over 3. And then if you got to subtract plugging in 0, but 0 cubed is just going to be 0. So we're just going to have to evaluate this. Pi cubed, we can't really simplify that. We're just going to leave that as pi cubed. And that's going to be over 2 cubed, which is 8, times 3. And 8 times 3 is 24. So our final answer is just going to be pi cubed over 24. So really simple integral.